Welcome to MRL. In this learning session, we'll be learning about the nets of solid figures, the parts of solid figures, how the solid figures can be visualized, and also how the solid figures can be drawn on a plain paper. Now, a solid figure, as we already learned, a solid figure is a three-dimensional geometrical figure which occupies space and has capacity to hold material. Now, every solid figure is made up of a polygonal base and the plane lateral surfaces. That means a solid figure has three very important parts. They are the faces, the edges, and the vertices. Now, what is a face? A face is a flat surface, a plane polygonal surface. A face is a flat surface, a plane polygonal surface. Now, if you look at this cuboid, we have got a flat surface here. We have got a flat polygonal base, a flat lateral surface, and also we have got different flat surfaces here, and all are the faces here. An edge is the meeting line. An edge is the meeting line of two adjacent faces. If I consider the face BFGC and the face EFGH, then they meet at a particular there is a meeting line between these two surfaces, and that meeting line is known as the edge of the solid figure. A vertex is the meeting or starting point of edges. Now, if you look at the point F here, there are three edges starting from F or three edges meeting at F, and that point F is called as the vertex of the solid figure. Now, if you consider as an example, if you study an example, like for example, this is a cuboid, it is also called as a prism with a rectangular base. Now, the number of the rectangular base means it has got four sides, therefore n is equal to 4. The number of faces is n plus 2, that is 6 faces. The vertices are 2n, that is 2 into 4, that is 8 vertices, and the number of edges are 3n, that is 3 into 4, that is 12 edges. So, and it is also true because we already learned about the cuboid. Now, we have to understand there is a very important relation called as Euler's relation. The Euler's relation states that the number of faces when added to the number of vertices of a solid figure or a polyhedron, then that is equal to the number of edges plus 2. That means F plus V is equal to E plus 2 is what is Euler's relation, and we have to verify whether this Euler's relation is true for any polyhedron or any solid figure. Now, let us understand, or any prism. Now, let us understand with an example. Then the number of faces in the cuboid are 6 faces. The number of vertices are 8, so 6 plus 8 is 14. The number of edges are 12, 12 plus 2 is 14, LHS is equal to RHS, and therefore the Euler's relation for a polyhedron is satisfied, and it is satisfied for a prism which is a rectangular based prism and also a cuboid here. So therefore that is Euler's relation. Please remember Euler's relation for a polyhedron. It is the number of faces plus the number of vertices is equal to the number of edges plus 2. Let us apply the Euler's relation for a pyramid, which is also a polyhedron here. Now, the pyramid is a triangular based pyramid. N is equal to 3. Therefore, the number of faces is 3 plus 1 is 4. The number of vertices are 3 plus is n plus 1, that is 3 plus 1, that is 4 vertices. Edges are 2n, that is 2 into 3, 6 edges. Applying Euler's relation, we have number of faces is 4. Number of vertices is 4, 4 plus 4 is 8, number of edges is 6, 6 plus 2 is 8. Again, the Euler's relation is satisfied for a pyramid also, which is a polyhedron. So, please remember that. Now, the nets of solid figures. A solid figure has 3 dimensions. If we cut the solid figure in a particular manner and spread it on a flat surface, we get a 2-dimensional pattern of the solid figure, and that is called as the net of the solid figure. Again, I'll repeat, a solid figure has 3 dimensions. If we cut the solid figure in a particular manner and spread it on a flat surface, we get a 2-dimensional pattern of the solid figure called the net of the solid figure. Therefore, in brief, a 2D pattern of a 3D solid figure, a 2D pattern of a 3D solid figure is called a net. Now, net enables us to analyze and measure the surfaces of solid figures. Now, let us take an example here. Now, we have a cuboid here. The cuboid has 6 surfaces. It has got a rectangular base, a rectangular top, and rectangular 4 lateral surfaces. So we can cut it open and display it. Now let us go one by one. So the base is here. We have got the base ABCD is the base here, and after the base please understand here very clearly. After the base we have got the front side, and that is AEFB, the front side. Then we have the top. We can go on the top. There is the top side here, then the back side here, and on the left and right we have the right side and the left side. So this is a 2D pattern of a 3D cuboid. Remember that three-dimensional solid figure, that is cuboid. Similarly, a cube can be cut open and displayed to get 6 square faces. So we have the base here, the right face, the left face, the back, the front, and the top. In all, we have got 6 square or 6 congruent faces, which is the net of the solid figure, that is the cube. Similarly, we have the net of a cylinder, and you know that cylinder has 3 surfaces: a curved surface, a circular base, and circular top. The curved surface, when the cylinder is cut open, we get a rectangle. So the rectangle is shown here, which is a 2D figure. Then that is the curved surface, and the top we have a circle, and the base also we have a circle. So this is the net of a cylinder. Now if you consider the cone, now cone, as you know, it has got a circular base and the curved surface, which is sector of a circle. So the net of a cone is the sector of a circle and a circle which represents a circular base. So this is what is the net of a cone. Now the net of a pyramid is a tetrahedron. It has got a triangular base. So we have got a triangular base here. It has got 3 triangular lateral surfaces. So we have 3 lateral surfaces representing the 2-dimensional pattern of a 3-dimensional solid figure, which is the pyramid here. Remember that. Now, how to draw solid figures on a plane? See, solid figures are 3D figures, whereas a plane is a 2D figure. So now how do we draw them on a plane? There are different methods of sketching. We got the oblique sketches and the isometric sketches. Now the oblique sketches are drawn on a square grid paper. The paper which you see here is a square grid paper. This is one small square. So there are many squares here. So this is a square grid paper. The paper on which the features of solid figures are being written. All the sketches of solid figures drawn till now are oblique sketches. The oblique sketches give an appearance or illusion of 3D figures. However, the measurement of the figures are not exact. So now whatever we have studied about solid figures, all the figures are drawn on a square grid paper. They are all oblique sketches. They all give an illusion of 3D figures, but actually they are drawn on a plain paper. But the measurements of the figures are not exact, although they give the shape of a 3D figure. Then we also can use isometric sketches. In isometric sketches are drawn on isometric dot sheets. They are the sheets with dots and in which the dots are placed at equal distances, and the sketches give an appearance of a 3D figure, and also the measurements of the edges are exact. Remember that. Now visualizing 3D figures. A solid figure or 3D figure can be visualized in different ways. We can view the solid figures from different angles. We can view the different sections of the solid figures, and also we can view the shadows, which give us the 2D appearance of 3D figures. Now let us understand this. Now viewing solid figures from different angles, we get 3 important views: the front view, the side view, and the top view. Now let us take an example here. Now this is a solid figure. The front view is a triangle. The top view is we have 2 smaller what you call rectangles, and the side view is this view, and that is also one simple rectangle. So therefore, for a solid figure we have 3 views, that is the front view, the side view, and the top view, and that is called as the viewing of solid figures from different angles. And the second one is the viewing different sections, 2D slices of 3D figures. Rather, if you take a cross section of a sphere, it is a circle. If you take the horizontal cross section of a cone, it is a circle. If you take the vertical cross section of a cone, it is a triangle. If you take the horizontal cross section of a cylinder, it is a circle. If you take the vertical cross section of a cuboid, it is a rectangle. So that is how we have the different sections weaved, that is called as weaving different sections, that is 2D slices of 3D figures. Now also weaving the shadows. If you get the shadow of a cube, it appears like a square. The shadow of a sphere is a circle, and the shadow of a cuboid is a rectangle. So that is weaving the shadows, giving us the 2D appearance of the 3D figures. Remember that.